What's up, everybody? It's Coach Sharf. Welcome back to my Algebra 2 notes videos. Today, we got a quick one. It's still in our realm of factoring quadratics, but we're looking at when we have some special cases when our quadratics fit a certain pattern. We can look for patterns to factor them. They're called polynomial identities. So let me share the screen and we will get started. All right. So polynomial identity. So basically what we're doing is when you're given a quadratic, you want to see if the quadratic fits a certain pattern. Okay. And again, just a reminder about what a quadratic is, because this was kind of how we restarted everything initially when I actually showed you all this in class. We did this before we talked about the regular factoring. So a quadratic is an expression, equation, or function. I don't know why I cut the N off. With the highest variable / exponent being x squared. So I got x squared minus 6x plus 8. That's an expression. 3x squared plus 12x plus 12 equals 0 is an equation. And then f of x equals x squared minus 25 is a function with the function notation. If you go back to the vocab assignment we did, the first one, the first assignment that we did, this isn't the exact verbatim definition of quadratic, but it's pretty close. But those examples are the three examples that were in the vocab assignment. I have something that has x squared. Again, it's my highest exponent. There's no x cubed, x to the fourth, anything like that. So when we're trying to factor this, if you're given any quadratic, if you're trying to factor it, you can try to look for these certain patterns. Okay. So to fit these patterns, my first term and my last term have to be perfect squares. So if I look at my first term and my last term, they're perfect squares, I should look for a polynomial identity. You know, again, kind of after the fact, we're only going to be looking at the one identity in particular, but for all four identities, this is what you would do. Okay. So here's my examples for this. So on the left-hand side, I just have the two terms. There's no x in the middle. So just x squared and constant. So I got x squared minus 9. Again, my sign, I'm not worried about my sign right now. Okay. Well, that actually kind of let me move. Yeah. Not worried about the sign right now. That's tricky. X squared 9. X squared is a perfect square. X times x is what gives me x squared. 9 is a perfect square, which of course is 3 times 3. So that's all I'm worried about with that. Let me actually go to the right now. So x squared plus 6x plus 9. Again, I'm just worried about the first term and my last term. So I kind of like playing with this. This is fun. So I'm not even worried about the 6x. I'm just looking at x squared, and technically, I guess I'm not worried about this plus either. Guess I can move that. X squared 9, so same idea. Okay. Now down at the bottom, 4x squared plus 25. So 4x squared is still a perfect square. Okay, it would be, there's my pen. It's not the one I normally use. It would be, dang, did that. It's not gonna let me use my little pad, so I guess I'm just gonna have to draw with my finger. So I can do that now. No. Let me unplug this. That'll work. Might have been a little glitch there. Yeah. Wonder how it's gonna show up in the recording. All right. So now let me do this. So now we could say, I really hope, I don't know how bad it's gonna be. I might have to watch that. I'm gonna keep going, but I might have to watch this and re-record it. 4x squared is 2x times 2x. So it's still a perfect square. If I multiply 2x times 2x, I get 4x squared. 25 is a perfect square. 9x squared would just be 3x times 3x. And then again, 16 is 4 squared. I'm not worried about the 24 in the middle. So these are your 4 identities. I have a positive perfect square trinomial, a negative perfect square trinomial, difference of squares, and sum of squares. So again, these are just kind of quote unquote standard forms. It all has to do with this A and B though. Okay. If you look at my factors all the way down, I have A plus B times A plus B, A minus B times A minus B, A plus B times A minus B, and then down here, A plus BI times A minus BI. So I don't know why these weren't erased when I saved this initially, but sum of squares is the one we're going to focus on. I do just want to show the other 3 real quick though. Just again, so y'all kind of have an idea. I'm gonna have to come over here to write a little better on my little pad. So if I had x squared plus 6x plus 9, okay? Yeah, I'm focusing on a squared and b squared. So if a squared is x squared, that means a is going to be x, okay? If 9 is b squared, another way to write 9 is 3 squared. 3 times 3 is 9. So if 3 squared is b squared, that means b is going to be 3. Okay. So if I were to factor this, it would be x plus 3 times x plus 3. That's how it would fit that. Where the 2ab comes in, it's 2 times a times b, 2 times x times 3, which is 6x. So trying to follow this pattern, we can do that. But even without following the pattern, okay, even without following the pattern, if I just straight up asked y'all, if I'm trying to factor this, what can I multiply to get 9 that adds up to give me 6? And this is plus plus, so I don't have to worry about any signs. What can I multiply to get 9 that adds up to give me 6? It would be 3 and 3. So it would just be x plus 3 times, it's supposed to be a 3, I promise, times x plus 3. Okay. So here, I could literally have the same thing, except 6 is negative. So I'm still saying, what do I multiply to get 9 that adds up to give me 6? It's 3. But now, since 6 is negative, I got to go x minus 3, x minus 3. So I don't even have to follow this identity, either of these identities, to get this. I could just do my regular factoring. What do I multiply, get 9 that adds up to give me 6? What do I multiply, get 9 that adds up to give me 6? So for our difference of squares and sum of squares, honestly, I could do it with difference of squares as well. If I had x squared minus 9, okay. If I had x squared minus 9, again, b is going to be 3, so 3 squared is 9. All right. There's no x term in the middle, so you can almost treat it like I have an invisible 0x here. And then I would say, all right, 9 is negative, so that means my signs have to be the opposite. What can I add up to get 9 that would cancel out to give me 0, which would still be 3 and 3, except now one is positive, one is negative. So those previous 3 identities, I could still do this, okay? My problem with sum of squares is if I try to do x squared plus 9, okay, this is still a plus 9. So if I'm thinking in terms of what we know, right now about if 9 is positive, if I'm looking at 9 being positive here, I got to say, well, both my signs are going to have to be the same to multiply to give me a positive. Positive 3 times positive 3 is what gives me positive 9. But again, if I did this, I would have the 6x in the middle. Okay. And then if this was negative and a negative, I would have negative 6x in the middle. So that's why sum of squares is different. So it's not just, it doesn't fall into our regular factor. Okay. Try to erase this. Doesn't fall into our regular factoring. So you just pretty much have to memorize this pattern. So a squared plus b squared equals a plus bi times a minus bi. So if I had x squared plus 9, which is really x squared plus 3 squared, a is x, b is 3. This would be x plus 3i times x minus 3i. And that is I. It's not an upside down question mark. I don't know what happened when I tried to draw it. Let me erase that. There. So again, sum of squares, you're really just pretty much gonna have to memorize. Okay. We'll kind of skip this one. I basically explained what I just did, but in a little more detail. Just 3 more examples here real quick that y'all can look at. And I'll leave this up for a minute. Again, y'all can, of course, even the videos I've recorded in the past, I don't know how much I've said this. Obviously, this is really only like the second video I've actually recorded this year, the 2022-2023 school year. If I have a slide up and I move on to the next one before I get done writing, of course, you can rewind the video and pause it. That's the point of it being a video. And I've been talking long enough now, or y'all should start writing this down. If you need to pause it just to finish getting these examples, you can. Again, it's pretty much just memorizing this pattern. Since it's a squared plus b squared, this is what I'm trying to turn all of these into. Okay. So a squared plus b squared. 36 is 6 squared. So it turns into x squared plus 6 squared, x plus 6i times x minus 6i. 81 is 9 squared, x plus 9i times x minus 9i. 256, 16 squared, x plus 16i times x minus 16i. So, even with that video, I went longer than I wanted, little longer than I wanted to, but that's just covering sum of squares. Again, the other identities, you can do your regular factoring to get those, what I kind of showed y'all, but sum of squares, again, is the one you kind of got to memorize, basically. You got a couple questions on your worksheet for this assignment on it. I know there will be a test question on the end of unit test with this. I would like to do another quiz before that. I don't know if I'll include it on the quiz or if I'll just wait and include it on the test. I'll probably just wait to include it on the test. So that's that. So again, it says polynomial identities, mainly focusing on sum of squares. You need to know that for the test. And you also need to know for those 2 problems on the worksheet. So as always, if y'all got any questions, let me know. Email me, message me in your mind. Otherwise, I will see y'all in class.